So I went to the E4Dev lectures last semester, and I really liked the community, talking to all you guys. As an undergrad, it was a great chance to talk to grad students. So I kept going to a couple of the weekly lectures, and this summer I actually got to participate in a great program. I wish I could show you pictures. But it was a great program in northern India, actually held in Ladakh. It was a workshop on energy access. And it was like my first real time, because I never really had experience doing work in other countries, so it was my first time like kind of looking at energy access in India. And we were specifically located in a mountain town, this small campus called Sekmal. It's a super sustainable campus where for the first time I got to like touch a solar panel and like see technologies like biodigesters and composting toilets and all these things that I only read before in books. And it was like all of my summer, it was definitely like the greatest time I had that summer. This beautiful nature, meeting new people from Masdar University and the UAE and Singapore and Canada, very like international crowd. Learning a lot of useful skills from anywhere from electrical engineering to like how do you deal with like local populations and kind of communicate effectively, and also just having a chance to learn about the local culture. So I just want to say, yeah, E4Dev, because I never would have found out for this opportunity if it wasn't even for like a simple email that I got that just said, hey, do you want to go to a workshop in India for the summer? And I was like, sure. And then I got funding, and then it all happened, and like I would have never had the opportunity without E4Dev. So thanks, guys. And now on to your future presentation.
What we're trying to highlight is just kind of some of the opportunities that we want to connect people to. So if you hear about things that sound interesting to you, but you can't find a way to make it work, that's what E4Dev is here for. We'd like to connect people to opportunities to research funding sources, that type of thing. So I will introduce our speaker. Co-founder and CEO of Kanoot, Tristan Jackson, grew up on an undeveloped Maine island without grid power or running water. He built his own home, including waste management and energy systems. He, with experience in El Salvador, Ecuador, Panama, and Morocco, he is familiar with the challenges of processing waste and generating energy in locations with limited infrastructure. Over the past 15 years, he has studied and tested renewable energy systems with a goal of marketing a low-cost waste management, energy, and fertilizer solution for agricultural communities. Having come to MIT to build a team and a company around this vision, Tristan and 3 other co-founders incorporated Kanoot in April of 2014, originally planning to build small-scale biodigesters. Over the past year, the team began working with a specialized set of microbes, which proved their value in treating many kinds of organic toxins. Tristan and the Kanoot team took a slight pivot from biodigesters to microbial treatment of large waste problems, and are currently working on plans for their first full-scale project in a landfill in Panama. So, welcome.
Thank you, Lily. So Lily started that lovely introduction, and partway through I found myself wondering, how did she know all this? And then I remembered, I think I wrote that down. But I think Summer here saw me take a nap about a foot from the professor in the class today. So there are 2 things that I'm going to talk about, which are what we're actually doing with our technology and in our efforts to bring waste management and energy solutions to the developing world. And I'm going to tell you a little bit about what that's like. And as you probably could guess, it can be a little tiring. I'll give you a little more background because I thought it was interesting. The first little presentation here, the very brief one about doing work in India, mentioned just touching a solar panel this summer. And I did build a home with off-grid power system and waste management system actually 4 times. So each one got a little better than the last. And I'm going to now show you 4 iterations of this company, each one a little better than the last. Started with doing things by hand, off-grid, out of necessity and at a very early age. Wired my first circuit when I was 4 and did my first whole house system when I was 8. So I grew up kind of thinking I can put together and make work whatever I want, which can be a good thing, and as you'll see, can also be incorrect. the first thing that we knew for sure was that waste was a huge problem for a very large number of people. Also, the need for energy and the need for a renewable source of soil additives to improve agricultural yields, ways of recapturing water. We felt all of these things come together, and there's a core technology that addresses them best. That's the use of microbes in airless conditions to turn waste into fuel and fertilizer. You can purify water that way, you can clean toxins from sewage, and you can add to the productivity of people's soil. And these are pictures that I've taken. I've been to over 30 countries, and in the process I saw a lot of situations that were a little bit shocking. And what brought me to MIT in the first place was that I didn't feel like I could live a fairly peaceful life in a fairly quiet place in a nice little home I built, while other people didn't have the first hammer to start with. Let alone the kind of technology that came fairly easily to me in the first world. I was off-grid, but I was next to America, and these people weren't. So we developed the idea of a transportable anaerobic digester. I'm going to go through these pretty quickly because there's quite a few of them. And again, this is showing our first version of this slideshow. When we were looking at Morocco as the market, one of our co-founders is from Morocco, and we were looking at farms of 20 to 200 cows. Then later moving into the slaughterhouse market, small-scale agribusiness, and on into the total bio-waste management of the developing world. We did all the things you're supposed to do in business creation, counted up the amount of input, the waste in this case, what its market value would be, looked at our competitors, some very good ones, and some of them from here, like Sanergy and Cambrian Innovations, very dear teams that came out of this university and which are doing great work in their own way. Our difference was that we had a system that was plug and play. For example, the Sanergy system, they franchise their Fresh Life toilets, but you have to collect in a bucket from the Fresh Life toilet and take it by hand or on a bicycle to a place where the waste will be broken down. And ours was an all-in-one solution, so it was more accessible and easy to use. And we actually built some tanks. We had partners at the University of Oujda in Morocco. It's Anas Afilal, one of the co-founders there. He's the Moroccan fellow. And we started processing chicken waste and other types of farm waste. We had a development plan that moved the company up in value and brought the technology down in risk over, as you can probably tell, we're somewhere along that way, and we didn't follow that path. One thing we knew we had to show that it would pay back. We made a lot of assumptions, of course, about the value of these machines based on the listed cost of waste management, and it is high. You have to pay to put waste into landfills, but it's actually illegal to put slaughterhouse waste into landfills almost anywhere, and in Morocco you're supposed to incinerate it. So we believed that we could capture the value of managing that waste a cheaper way. And our original team, very excited about it, motivated, filled with relevant domain expertise, sort of. So we got about that far and paused, came at it again through competitions and courses, and we wanted to, get the problem statement up front in people's faces and make it look very dangerous in red. So we changed how we were pitching. We got more specific about building the technology into a shipping container, taking in about a metric ton of waste per day, producing 80 cubic meters of biogas, 270 kilos of fertilizer. We worked with engineers here. I'm not personally an engineer. I've hacked things together my whole life, but always just on the fly, and learned a lot about how to do it with the planning process and with testable assumptions. Came up with a pretty good design, which once again compared you see we're always in the upper right, once again compared favorably against our competitors, who by and large had much more expensive or much less functional equipment. We're still looking at Morocco, and we had counted up the waste again, and we had translated that into a market that gave us $60 million total addressable market in the first year, and had a great impact in the world, taking CO2 out of the air and producing a lot of fertilizer. Very exciting. We went over to Morocco. We met with OCP, the largest company in the country, the largest fertilizer producer in the world. They wanted our nitrogen, they wanted our phosphorus. ANPO wanted us to help them get rid of their chicken waste. The National Association of Chicken Farmers, the universities in Casablanca and in Ujda said, we want to put grad students on this, we want to work with you. It's all very exciting. We met Mo, we were using the name Mo. In your customer persona, I'm sure you guys know, especially if you've read Bill Elliott's Disciplined Entrepreneurship, you've got to have an actual person. And so we met Mohammed, Mo, slaughterhouse producing about 13 tons of meat a day, which equals about a ton of waste. And he wants a biodigester, he needs one, but he can't afford the expensive models that are on the market. So we were going to give him this piece of equipment with no upfront cost, the lease model. It would replace his tipping fees at the landfill, and it would replace his need for butane to boil water in a slaughterhouse, and he was going to be able to save money while paying us over time. We made these realistic, in our opinion, projections which completely failed to impress the VCs, and we were, again, united around shared values. We made our picture a little better, or so we thought. Then we realized these slaughterhouse owners don't pay anybody to dump their waste. They dump it in the river, and nobody's enforcing the regulation. There's no money to be made there because they're not spending any money. We thought they needed butane to boil water in the slaughterhouse, but they were using this stuff called bunker fuel, which is about $20 a ton. And it's like if you made coal into a liquid and had it a little dirtier. That's the kind of fuel that we're talking about. They did not care about burning it. It was cheap. And so all the financials that we had made no sense at all. So we started looking for somewhere where we could count on enforcement, where we could count on costs that farmers faced, and we started looking at the cows around Massachusetts and seeing piles of money. Waste to wealth. We were going to go get it. And managing the biowaste of the world still is a huge opportunity. We counted it all up again, $18 billion total addressable market, and we really got in on how's this box going to work. We spent more time designing a system that would be compatible with all the different setups that we saw on different farms, one that could be filled automatically from their gutter scrape system, one that could be filled by tipping a wheelbarrow. Came up with a list of the farms in the area and went out and we met John Hornstra, who's in Norwell, Massachusetts, not too far from here. Third generation dairy farmer. Electricity is his second largest cost driver. So now we're thinking we need to put a generator into this box. And not just because electricity is so expensive for John, but also because that enables us to get carbon credits. So we can take advantage of the incentive markets in Massachusetts. He has 60 cows. They produce 3 tons of manure a day. There's no biodigester on the market that fits his need. He's just a little too small. So we made the TAP system, the Transportable Anaerobic Processor. We designed the volume and the temperature controls and the grinders and the mixing tanks and came up with how to put it all together for under $100,000. The next best option on the market was $500,000, so we knew we were going to make money. And we were going to give him excellent customer service as well. We found out that he was spending $20,000 a year on sawdust, and we could replace it with the dried part of the effluent from the digester, which actually works better than sawdust because it's been consumed by the microbes, nutrients have been removed, and it actually has less fungus growth, less flies gathering than if you just use sawdust. So this is a great thing. We knew John would be happy. We took our time coming up with the materials and a thermal balance, the whole conversion of solids to gases, what we could expect for energy, how we would turn that to electricity, what goes in and what comes out in dollars. And it was beautiful. We were going to make $22,000 per unit per year. And we were going to make a bunch of units, assemble them on an assembly line, and roll them down the road behind semi-trucks, because a shipping container you can easily move anywhere, plop them down on farms, and rake in the dough. Once again, of course, we're in the upper right. And we really are. I mean, these other guys, we did check with engineers, could this be done? Engineers that are in the job of building things, not just people like us in school. And one of the companies that we asked pulled out a set of plans, and it actually had one of those competitors right there, the Harvest Power name on it. So they had made one for them for $370,000, and they said, how do you think you can make yours so much cheaper? We showed them the design, and they said, wow, this would work. Let's cost this out. They went line by line, and they said, you're absolutely right, we could do this. And we had established a contact with our beachhead market. We knew what to do, we were ready to go, and now our curve was starting to look more like what people told us it was supposed to look like, because we made it look like that. That's what they want to see. But we were relying on getting some non-dilutive capital to start. We applied for grants. We continued researching customers. We took our team out to farms, and we eventually found that the farmer didn't want to use the output from the machine for sawdust because he didn't like the color. He thought it wouldn't be attractive to people who come to visit the farm and see the cow standing on something brown, even if it's actually cleaner than sawdust. And we realized it just wasn't going to work. He was not interested in having that thing put there. As excited as he was about what it could do and that it might work and what a great product it would be and how everyone would want one, when it came to actually placing it, he just said no. We didn't get the catalyst grant. So, that was December. We went back to the drawing board. In the meantime, we had met a microbial waste treatment expert with 30 years experience with a blend of archaea microbes that can eat practically anything carbon-based that you would want them to eat. They are completely incapable of eating living things, virgin plant oils, or synthetics like plastic. But they can eat cyanide, they can eat toluene, xylene, gasoline, kerosene, oil spills, engine oil. They can eat polycyclic aromatic hydrocarbons that cause cancer. They can eat all these persistent organic pollutants, or POPs. And we realized we have microbes. We can produce 10 tons of microbes a week. That's enough to treat 2 million square feet of surface area. And there's a lot of surface area to treat out there. There's landscape, old industrial brownfields that real estate developers are trying to clean up, and they're just removing the dirt and putting it in a hole somewhere else, where our microbes could make it clean and safe again. They've been used for decades. They've just never been successfully commercialized. Why don't we take what we have and go into microbial waste treatment? There's a lot of waste. And we're starting to get closer toward what we're actually going to do. There's 10 million tons of solid waste produced each day. Almost 2 billion gallons of sewage sludge. And you might recognize this picture. Back in Panama, we had the same picture before. I spent time in Panama. I went to Panama City and saw a population of 1.5 million people that were dumping many of these things that our microbes can break down into one great big pile. There's only one landfill in Panama that's approved for use, the Cerro Patacon landfill. Our microbes, this is probably near impossible to read, but they've been tested by third parties, and what you're looking for is the alkenes, the polycyclic aromatic hydrocarbons, the top two rows there, the almost 100%, 99.9, 98.5, as compared to, say, like the one right above the polycyclic aromatics, that product was only able to break down 11.2%. So compared to all the products that the EPA has approved in the US for use on land to treat toxins, ours is by far the most effective. And there are a lot of waste heaps throughout the world. The Seropaticon one I mentioned, which we'll talk more about, it's the 120 hectare only landfill for the population of 1.5 million. It's one of about 4,000 of that size around the world. And we're looking for the owners of these landfills to sell them microbial remediation systems. We've made more than just contact. We have a strong relationship started with the owners of this landfill, who also own 13 others throughout Latin America. And we're planning a pilot project here, which if it proves our concept as we believe it will based on lab results, we will then replicate and proceed with the other landfills of this holding company, and then move on to other landfills around the world. Here's Seropaticon, over 10 million cubic meters of trash, of which 77% is organic. It's receiving 2,200 tons of solid and almost 500,000 gallons of sewage sludge a day, because Panama City has flushing toilets but no sewage treatment plants. 500 trucks a day drive around the city, fill up tanks full of sludge, drive out to Seropaticon, and dump it in a pile. Which is not just worked over by trucks like that, that would be kind of nice-ish, but actually there are hundreds of people, as you might imagine, living around there, crawling over the pile every day, picking for plastic and bits of fiber, bits of metal, whatever the waste collector higher up asked for that day. And so they're exposed to all kinds of toxins. And this big pile is open to the air, of course, gets rained on, water comes out the downgrade side, and there's about 30,000 cubic meters of leachate, as they call it, in these pools. But these pools, as you can see, that's the lower side of the landfill, the high side of the pool. The low side of the pool is a little bit lower, and it's right over a river. So the sludge goes out of the landfill, into the pool, into the Macombo River, into Lake Miraflores, into the oceans on both sides. And on the way flows through tens of thousands of people's water supply through indigenous villages. Looks about like this. Now, the rain on the landfill drives the water out the downgrade side. It had been just filling up a set of pools and dumping right into the river. Off the record, sorry camera, but that's not really what they're supposed to do, but they do have, it's officially condoned. It's not the right thing to do, clearly, but nobody knew what else to do. So the best practice is reverse osmosis. That's the current state of the art. And they'll put a reverse osmosis system in at the top pool, another one at the second pool, and they'll push the liquid through a filter under a whole lot of pressure. So that really they're separating the water from the solids and toxins, and then the water continues on to the river. The toxins go back on the pile, not eliminated, not treated in any way, just concentrated and returned to where they came from for now. Reverse osmosis also is a pricey problem. It's a pricey solution to a problem. The installation of the system up front is $12.4 million. Operating costs every year are $2.3 million. That's about 4 times more upfront and more than double per year what it would cost to treat the same leachate with a microbial remediation system that we can design. So there's the figures on the cost. And worst of all, it's just ineffective. I mean, from a financial perspective, as a business, these numbers are good in terms of what we're looking for as our path to commercialization. Because we want to get a big customer with an expensive problem with the ability to pay with a budget that's already being used to solve the problem, so we can get money coming into the company, build it, scale our solution, and then get back around to helping Mo, the farmer in Morocco, who can't really afford to change the way he's doing things now. These guys can afford to do it differently, because to do it differently, is also cheaper. But we looked at it first from an economic perspective, and then we realized, wow, this waste problem is huge. These are really bad toxins. These are leaking barrels that used to hold pesticides and herbicides. These are just tons of bioactive little critters, you know, E. coli and whatnot from all the sewage. It's going right into the water. Thousands of kids getting dysentery, thousands of people dying over time. And around the world, millions. So this is a really big issue. And it's getting bigger. Obviously, you all know this part. 3 billion new middle-class consumers coming online in the next 20 years or so. They're going to use more flushing toilets. They're going to use more things like Clorox, things like, you know, just the typical house cleaning supplies that you can buy off the shelf. They're going to be buying more of them. And our microbes can break them down. It's a quarter the cost up front, half the cost on the OPEX, and we can completely destroy most organic toxins. Things like bleach, and things like used engine oil. They've been tested, they're safe, they're non-GMO, and we can make as many of them as the problem requires because, as we like to say, our workforce doubles every 20 minutes. Under ideal conditions, the microbes multiply pretty quickly. You can't read the slide, but it just says that we, by the way, are 50% of the original team and 50% new. Got Mike in the back here. He was supposed to throw little bits of things at me and heckle me throughout the whole talk, so he's slacking on the job.
You were doing great.
But, and you're all welcome to throw things and heckle me too, if you have any questions or anything to say. We're almost to the end of this, but just so you know about adjacent markets, oil spills put over 1,300 kilotons of oil into the oceans every year. Industrial solvents are turning rivers colors they never should be. They use cyanide to mine gold. Our microbes can break all that stuff down. But what they do is they use it as their food and energy source. They build the carbon and the hydrogens into their own bodies in the form of omega-3s. Archaea microbes don't have a nucleus, so they're a very cool little life form. These guys have been around for like 3.5 billion years. They've survived all kinds of conditions, and they can eat anything that would just about kill us, other than heavy metals. We can't deal with the heavy metals, but if it's a solvent, if it's cyanide, if it's and you know, there's mine dumps behind dams, just sitting there waiting for the day the dam breaks, waiting for an extra heavy rainfall or a little earth jiggle or something like that to come pouring down. As we've seen in the news in the last couple of years. Not a pretty picture, and something needs to be done about it. But when these microbes come in, they eat cyanide, they build their little bodies out of it, and as their population doubles and doubles, suddenly they've eaten everything, and the party's going full tilt, and then it just stops, and they all die, and they are immediately consumed by the natural bacteria and things like fish. We've done experiments breaking down waste in little controlled containers and all that, but we've also taken some engine oil, mixed it up with a handful of microbe powder, dropped it in a fish tank, watched as it changed colors, started to put off some bubbles, and the fish eat it because they start to smell the omega-3s, and it has become fish food. Those fish are still alive and happy today. What this is really all about, you know, we're trying to keep our focus on Seropaticon. We're going to do a pilot project in Seropaticon. We really are. We know what it looks like. We've got the design. We've got the site. We've got the partners. But in a bigger picture, we want to change the whole way that people view and use and manage waste. We like to say things like it's only waste if you waste it, or waste is a terrible thing to waste. So it really should be an input. You know, right now we're getting fertilizer from fossil sources, and that ends up increasing concentrations of nitrogen and phosphorus in waterways. You get algae blooms. I don't know if you guys all saw the Great Lakes last summer. Looked kind of like antifreeze. It was like neon green with a tremendous algae bloom that killed all kinds of fish, made the water toxic. And that shouldn't happen. We really should be using a closed loop system. We've got these molecules. These are molecules, they're valuable stuff, biomolecules from food waste. And we can take the energy out of them, put that back into human use, and take the nutrients, the potassium, the phosphorus, the nitrogen, the carbon, and put that back into the soil in a carefully managed way so it makes more food, it builds a soil base, and then we get to, we just keep running the virtuous cycle, as opposed to the fossil fuel nutrients are usually, they're water soluble, so they can be sprayed with irrigation, and they run off quite easily, as opposed to the buildup of soil that you get when you break down organics and then add them back to where they came from, which tends to be more bound, more accessible to the plant roots. It's all around a much better system, keeps everything healthier and happier. So in the first phase of our new business, the microbial treatment of waste around the world, we are identifying sites through partnerships. We've got the Cerro Patacon landfill, the other 13 that are owned by the same holding company. We intend to branch out from there. We have a system design. It's secret, but it's very cool and it works. And we want to set it up at no cost in the first scenario, but then sell the microbes ongoing on long-term contracts. And then as we scale, expand our microbe production capacity and sell those microbes for oil spills and for other waste problems of all types that don't require us to go in and build a system first. We are still in the upper right corner. No surprise, right? The status quo is very affordable, but it's very bad. There are companies like New Logic making reverse osmosis systems. Not so affordable, not so effective. There are some people with microbes, which are doing a pretty good job, a little more affordable, a little more effective, but they're not as good as our microbes. We have the best in the world. So, the big opportunity as population increases, there's a lot of landfills, consumption is also increasing, so that also means more waste. The market for bioremediation is growing. People are going to try to beat us to it. There's a lot of competition, of course. There's perceptions on what, I can't go and grow food on something that was waste. It'll take a lot of work, and it'll take a lot of people. We obviously have no illusion that we're going to capture the entire global market, but we are intending to be a major player in it, and we hope some good people do try to copy us and do succeed, and what we want to do is solve the problem. Once again, our curve looks beautiful. Based on what we can produce for microbes today, how we intend to scale our sales, discounted future cash flows to the present moment give us an NPV around $2 million, and that is the show. So, any and all questions? And if you want to start throwing things at me, I know I never run through that show before. I just took 4 other shows and put them together. Thought it would be kind of fun, but.
Yes, question. You mentioned you have been using the discipline entrepreneur framework.
Yes.
Do you find any challenges with the framework as it applies to, let's say, a sustainability project?
Funny you should ask. There is a new course at MIT called Sustainability-Oriented Innovation. And it teaches students how to launch concepts into the market, whether through a new venture or an existing company, or even as an investor, how to correctly value and bring those things to the public. And the core of that course is a so-called sustainability overlay that goes 1 through 24 with the 24 steps and asks the right questions through a sustainability lens to help inform the sustainability-oriented innovator how to go through the discipline entrepreneurship process with a sustainability focus. And I wrote it. And it's being used in a course that will be available through Sloan next spring, where the first version of the course is, there's 13 of us, a dozen of us, that are creating some case studies and some other materials to go with the overlay. So we're building the materials that will be used in the later course. But if you're here, spring 2016, check out 15385, Sustainability-Oriented Innovation.
Well, and just to follow up, you mentioned some of your potential clients, landfill owners in Panama and
Mhm.
perhaps throughout Latin America. Um, what is the size of the market based on your analysis? Just broadly speaking, in Latin America, what is the potential there?
So the Cerro Patacon landfill is very large. It's not the largest one in Latin America. That one's outside of Rio de Janeiro. The capex on the system that they're putting in now, like I mentioned, is 12.4 million. So if we can come to landfills before they've invested in reverse osmosis systems and say, you know, here's one that you can have for only 3 million, and ongoing it'll only cost you $1.25 million per year to run instead of 2 to 2.5. We believe we'd be able to sell to most of those landfills. So on the CapEx side, that would be about $60 million worth of construction to do, and then ongoing, we'd be looking at about 20 to 30 million a year in Latin America.
Will the government be involved in any point? Local
Oh,
government, for
yeah,
example?
I mean, surely, you know, anything that involves pretty large-scale stuff, you're going to bump into the other large-scale players, which are always include the government. So sometimes that's a positive thing, sometimes it's a challenge. They are working to modernize. Panama City was the second fastest growing city of 2014, and they're doing a lot of work to make it a world-class city. So they're going to be putting regulations in place. They're going to be trying to enforce those regulations, and that'll work in our favor. They're also going to, you know, they're government. They're going to want to tax things and stuff like that. I assume, from my experience so far in Panama, that's going to be one of the easier places to work. I'm not, you may have noticed, going further to Argentina, and if you don't know why, check the news. There are going to be some really difficult markets, really difficult situations with some really difficult players. No illusions about that. Hopefully we'll get some help along the way. We know we're going to get some resistance too. Summer?
Will too many microbes change the ecosystem, especially if you dump too many into the ocean and too many fish accumulate there, and then, like the farmers, you know, fishermen, they have to like go there, and it would change like the global.
Great question. So everybody always asks, sooner or later someone says, what happens if they get away? Are they going to come and eat us? Are they going to eat the tires off my car? Or what are they going to do? They have been approved for use on land by the US EPA, which is like getting something through the FDA. This is not an easy process. So to satisfy the EPA that they're safe is a considerable amount of work, and it does mean you can probably count on them being pretty harmless. They have not approved them for use in waterways because they just don't know. And studies have not been well controlled. Microbes have been used in water, and then people have tested on beaches side to side, and where it's down current, well, there they are. They clearly spread. The thing to understand about these microbes is that they're naturally occurring. They're not GMO. They've been gathered from around the world, from very difficult parts of the world, sulfur springs, oil wells, gas fields, underground volcanic vents. And that's sort of their natural habitat. When you release them into, say, the Amazon, something else is already there that's better suited to that environment, or the microbes would already be there. They're as free as the birds, and they go anywhere that they can. They're actually a little freer than the birds. We have over 500 strains of archaea microbes in our digestive tract, and by cell count, this is a cool little stat for you, by cell count, microbes, so other living things inside of us, are 95% of the cells in our body. Like only 5% by count is you. Crazy? But they're symbiotic with other life. We need them to live. We couldn't live without them. We're trying to come up with a good tagline about, like, you know, we love the little guys, or the little guys keep us alive. You know, something that says what's true and is easy to understand. These little things are really pretty friendly to our lives. They don't compete with us for food source. I have eaten them myself. They're pretty safe.
So not an area I know much about, but I'm curious if you could talk about the production process of the microbes, how expensive it is, what goes into it, if you guys have a competitive advantage in doing that. You mentioned they come from volcanic vents, so I'm just,
Yeah.
be as simple as possible. or a bit,
Simply
talk-
put, it's a secret.
It's a secret.
No, we do have a facility. It does have tanks. Microbes are grown in the tanks. I can't really tell you much more about it.
Is it thought that when you sell a system to a client that they add the microbes to something and they kind of nurture that population, or do you have to keep feeding?
So what makes the
New microbes.
consortium effective is that there are about 100 different strains in there. And that's why we can put the product on the market, and it will be very challenging for someone to replicate, because they can be then applied to any of the waste situations that I described, and 3 to half a dozen or so will be best suited to eat cyanide. And when you come back 2 weeks later, that's all you'll find. The other 96 of them died. So when you apply the product to a waste situation, it responds to that environment, and what's in the tank changes over time. So if you've got a landfill and there's variability in the waste flow, you've got to keep adding some new product every so often, or it will become ineffective in dealing with the things that aren't dealt with well by the strains that became dominant. That all make sense?
I just have a question. I worked for a little while for a company that was trying to do provide electricity to people with very little money, and it was it was really hard, and it didn't work very well. And I'm probably oversimplifying, but it seems like what I'm seeing about this last iteration of your company is that you're going to start your customers are now a big. You sort of said you're going to start with this big company that has money and can replace something they're already doing with what you have, and then you can eventually go back, hopefully. Is there any way, this is a big question, but like, is that the primary difference, and do you, like, if you're starting at, like, did you see any way to carry on with your initial plan of, like, helping out Mo, or is this the, like, key to,
So I started the talk with the story of falling asleep in class this afternoon, so you'll hopefully forgive me. That was my disclaimer for being completely brain dead. That's an excellent question, and I completely forgot to mention one of the best parts about this project, which is that the company managing the landfill is installing an $18 million, 8.1 megawatt landfill gas turbine. All right, so they're drilling extraction wells into the landfill to take gas out of it to produce electricity for the surrounding metropolitan area of Panama City. Our microbes in air, they produce some carbon dioxide and they make themselves out of the material they're eating. Without air, in anaerobic conditions, they don't produce carbon dioxide, they produce methane. So when we take the treated water from the leachate pool and cycle it back to the landfill and inject it into the extraction wells, the gas production of the pile increases. So the total volume decreases. That's why it's important that I mentioned it's 77% organics. That's potential fuel. And by adding microbes to it, we shrink the pile faster, we get more energy out of it, make more space in the landfill so another pile doesn't have to be made somewhere else. This is an E for Dev talk, and we're still talking about energy for development. These microbes do produce energy from organic waste. And our hope is to use microbes in addressing waste streams of all kinds, including mow the farmers' cows, including toilets in underdeveloped areas, including toilets in the first world as well, where we hope to, and you may not know, everything that goes down the drain here does go to anaerobic digestion out on Deer Island. Probably you knew that, but that's a nice centralized system. We're interested in getting back out into the rural communities to the distributed waste flows and being able to develop and market a low-cost, effective solution that converts that waste to cooking gas or to electricity that they need, and to fertilizer, recaptures water and makes their rural setting, more livable, higher quality of life out there.
Yes, on that point, I think it was your first or second slide, you said small-scale anaerobic biogas digesters were not economical. And I'm wondering how much of the insights from this project, where you started with that vision but then moved to the large scale, which is obviously much easier from a business model perspective, but how portable are some of these solutions, both the micro production, the service that has to go with the maintaining it, and the infrastructure around building these things to the small scale?
So let me clarify. Not economical is not the right way to put it exactly. I think I probably did say that, but what I meant was that's the wrong place to start as a startup.
Okay.
When you have incredibly limited resources and incredibly limited time, very few people, and you're getting paid nothing, it's really hard to scale up a hardware solution that you then have to provide backup or warranties and deal with leases that people will default on. All those complications are just outside the range of a startup team of 4 people that are still in school. A company can do it. A company can make a product, have an R&D department, develop a unit that's both safe and affordable, and roll it off the line and provide support for it. And we do intend to do that. We believe it's an economical and a viable solution to distributed waste flows as well as these big concentrated ones. And someone may get there before us. There are some great teams that are working on that right now. We just, partly because of the disciplined entrepreneurship way of thinking, we realize this is a great way to make a small fortune if you start with a big fortune and you just make it smaller. But this is no way to get off the ground as a startup with no resources.
Any more questions? No, great. Well, thank you, Tristan, so much for your talk.
If anybody wants to talk to me, I'll hang around for a little while if you have direct questions. And you can find us. We do have a very rudimentary website, Kanoot.co. I didn't put my email on the last slide, but you can get it. And we do have a project in progress, which we're very excited about. If it's exciting to you and you want to learn more about it or maybe participate in some way, please talk to us.
Thanks again, Tristan.